Before I introduce myself, I will tell you roughly what I hope will be part of this talk, and I'll try to do it as quickly as possible. I'm trying to squeeze a couple of hours into half an hour or so, or 45 minutes, actually, I was given. And I think, to a great extent, I won't even use some of my slides. I'll first introduce myself and talk about the problems and consequences of long-duration isolation and the problems of a group under such circumstances in spaceflight. And then we'll go into countermeasures and research done in this area. And then I'm skipping part 3. That's why I kind of removed it in case you're wondering why there is only a part 4. That is group dynamics and then the future Mars. Partly because group dynamics is a very important field area which affects everything, not just spaceflight, but whatever we do in life, whether we are working in a team somewhere. So all of what I'm talking about, some of it will not be applicable to your everyday life because you aren't going to be in weightlessness very often unless you join the astronauts for hire or whatever, and then some of it will indeed apply. And it's very good you had your methods because I'm not covering anything like that at all. So it's interesting. So I'll first introduce myself in case you're wondering who I am. Daniel has already said something about me. I started my life as a nuclear physicist trying to find the building blocks of matter. And then I totally switched. Partly I had an idea that I wanted to go from the smallest building block. Ultimately, I was interested in astronomy and cosmology and outer space, of course. But I wanted to also understand, along the way, the magnificent human body. And this was also a goal I had. And so I decided I was getting a little bit bored with the nuclear physics, where we were about 15 people for 7 years searching for some 16th decimal point of a weak interaction or of the measurement of the weight of an electron or whatever, and it was really getting a little bit on my nerves. So although physics is still my inner love, you might say, I went into neurophysiology, partly quite by accident, because across the road from our laboratory we had the Neurophysiology Institute, and the professor there was planning the first experiments on the first European experiments on the first Space Lab mission, which was planned to go up which went up into space in 1983. You may or may not have heard it. Went piggyback on the shuttle, and this was a magnificent mission where we had something like 100 scientists from all over the world, but mainly America and Europe, and we had to prepare everything for the crew who were going to perform roughly 100 experiments in 7 or 8 short days. And you can imagine what kind of stress that was. Not just for the crew, but for the experimenters. They've been waiting for years, some of them students trying to get their doctor's theses done, and after about 5 years of trying, giving up and trying to do something else because the space shuttle took far longer to go up into space than planned, they stopped the Apollo program and replaced it with Space Shuttle, but somehow they had a 15-year gap in between, which was not very good planning. This is part of the game of politics, which unfortunately is the real part of the stress that one has when one tries to go into space. It's not just engineering, it's not just psychology, but it's also politics. And that's the part we don't like very much. So, what did we do? We had this wonderful set of space missions, and I trained the crew for them and did a number of horrible things myself, which I would have liked to have some anti-stressors, where I got motion sick. We had to do parabolic flight where we only had 30 seconds to do an experiment, and we couldn't get off the plane if we were getting sick, and I got sick. I got very sick on my first flight. That's another story. And I went on and on into human space medical technology, where I accepted a post in industry. I decided I should try out leaving the university academia and see what the real world is about. Well, it wasn't quite the real world because space industry is not quite the real world. But I did that, and I did a little bit of human medical technology, human spaceflight operations, and during my course of that work, I was very much exposed to a lot of so-called psychology experiments. These were scientists who their principal aim, despite their first idealistic reasons for entering their fields, was to climb the academic ladder and become, from a lecturer, an assistant professor, and then an associate professor, and maybe a full professor, and try to get as many papers published as possible. And if they happen to be psychologists, well, you do measurements on people, and then you try to write papers about it. And if people make a lot of mistakes and they are problematic and they break down and they have all kinds of horrible reactions, then all the better, because there's all kinds of analysis you can do. And if everybody is getting along wonderfully and they have no stresses and no problems, then you have no publication. So the last thing these psychologists wanted to do was to help people. So many people enter psychology with the naive idea that they're going to become helpers of mankind and helpers of human beings. And in the end, they don't quite do that because they have to earn their money. And if you're in academia, you have to publish or perish. So that discouraged me very greatly, and that's what got me into entering the field of applied psychology, because I said, if they can't do it, then I can do it. And that's what I started doing. I did this on the side, and it went on, and I ended up lecturing at university since the mid-90s at Concordia University, and then since the year 2000 at University College London for about 13 years there, in the area of space psychology. So that's not what I got quite trained to do, but it's amazing what one will do in life after one's training. I got 3 degrees in physics and mathematics, and I ended up spending a lot of time doing very different things. Well, I was involved in a very critical mission, and that was the STS-107. Has any of you heard of this mission? STS-107. STS-107 went into space in 2003. Although the space station existed, it was not going to dock with it. And unfortunately, that was the mission where we lost the crew. It disintegrated on the way down. And that discouraged me very, very greatly. That was the first time I was involved in a mission where all the crew got killed. The previous one was the Challenger, which I'll talk about, because this is part of the stress part and part of the psychology, but not just of the crew, but of the ground. We sometimes forget. We think about the stress of the crew, but actually you have a lot of stress and a lot of decision making and a lot of psychological problems with the support people on the ground. So for every crew member up there, you have a few hundred people working on the ground at the same time, continuously trying to support a mission. He is not alone. There is no such thing as the lone hero. He gets the fame, maybe, but there is a hell of a lot of work on the ground, and this is part of the whole problem. And after that mission, I was extremely discouraged. All 7 crew members were friends of mine, and they were an astounding, really wonderful crew. And we had all kinds of plans of meeting afterwards and continuing our relationship. So it is very discouraging losing them. I just would add one thing. This was the only crew, if ever you are involved, but try to remember this. I have trained a number of crews since in the 1983 Spaceflight 1, in 1985 D1, and then the Mir mission on the Mir station in 1996 and 1997, and then this crew in 2003. And in all of the previous missions, the crews agreed to be trained. They were sometimes less or more difficult, usually a certain degree of their prima donna-ish characters. They were very important because they were flying into space and they were astronauts. So they were often extremely critical of anything and everything we did because they felt important. The STS-107 crew was not like that. They actually showed interest and even told us that our training was going very well. And they even, when I apologized for the horrible equipment they had to use because it was not, the man-machine interface was not very good and the human factors part was not very well done, they said, don't apologize, that's wonderful. I was really surprised. And then during the mission, near the end of the mission, the crew called down, one of the representatives said, and we would like to thank you, Jim Kass, for the work you have done with us. I had never had a crewman thank me for the training after the mission. And he thanked me before he came down, and I think they realized that they were entering a very critical phase and they may not make it to the ground. And it was the only opportunity they had to thank me. It was a very, very sad situation. Anyway, so I decided I was getting a bit discouraged with the human spaceflight part, and I went into some other areas of work. I did telemedicine and e-health because we were very much involved in remotely measuring the health of the crew. And then I went into integrated applications where we use satellite services for getting a lot of things done. And then finally, knowledge management and lessons learned. I thought that's the last thing we should do, is try to learn from the past. Now, I don't want to spend too much time. Here is some areas of reading in case you want to read on these themes. There are the problems and consequences of long durations missions, and some of these are, you might say, well, what environments? Are we just talking about long duration space missions? Well, actually the similar problems, other than the absence of the weight of gravity. I mean, gravity is there, but we don't really feel it. We are weightless in space, in orbital spaceflight. There are other environments, whether it be extreme environments on a mountain or in a submarine or under other circumstances, where the problems we are talking about are similar and the solutions, the consequences, the countermeasures are similar. As also was pointed out by Mindy, a lot of the training that could be done to prepare you for spaceflight could help you in many other things as well. But not only in extreme environments, you might think this is wonderful. We have come here tonight to talk about this psychology of very interesting and extreme situations, and it doesn't apply to my everyday life. Well, it does. It does apply. You have groups, you have stresses in everyday life. When you go back to university, or you're a student, or you're working in a company, you're working in a team, and even you have your own team in your own family, for example, and you have problems with getting along the dynamics of that team. And this is also real life and everyday life. So these solutions are not just esoteric, they're for our everyday lives as well. So the space domain, it's a very strange domain. We think of it as being something very extreme. People think the space station way up there in the sky. How far is the space station away? How much? Yeah. Not very far. You know, from here to Groningen or some, it's about the same. It's not very far. It's, we think of outer space, it's not really. I mean, it's just orbiting the Earth from very close. So nothing fantastic. It's sold to us as being some fantastic, but it's not. Well, what was a little bit more fantastic was the moon. How far further away was that? Very close, yeah. Your answers are correct. Essentially, 1,000 times further, 400,000 kilometers. Yeah. So that was a respectable distance. So the moon missions were really critical and psycho-stressors. If you've seen the film Apollo 13, it was fairly good. It was not just simply Hollywood imagination. It was actually a fairly well depicted scenario of what happened, the critical areas on the ground, operations. One of the ground operators, who is a friend of mine, was telling me that the team on the ground, he was in the team on the ground, and I said, how old are you? You must have been fairly young in those days. And he said, yes, I was only 28. And I said, and you played a key role? He said, oh, I was one of the older members of the team. The average age was 26. The average age of those people on the ground during Apollo 13 and these were fairly young. Yes. Nowadays it's not the case. But it is possible, and it's not the case that we need these people with 30 years experience. I'm always saying when we have a lot of experience we should pass it on to others. But the young people were running the show in those days, and they were running it very well. So yes, you can achieve something. Believe you can, and you will. But if we're going to go from the moon and go to the next stage, what's the next stage? Mars, as was mentioned. We're getting a little bit further. Any ideas how much further?
2 years worth.
Yeah. Could be 1 or 2 years, depending upon whether you want to go there and come back right away. If you just stay, because Mars has an orbit which is lopsided, and the farther end of the orbit is about 400 million kilometers. So we're talking of 400,000 to another factor 1,000. It's interesting. Now, when you talk about science fiction, you're going to another star, right? If you watch on television, it's quite simple. Where's the next star?
Light years.
Yes. Somebody is very well informed. What's the name of it?
Alpha Centauri.
Yes, excellent. 4.3 light years away. So, if you are going at the speed of light, which is how fast? A few 100,000, 400,000 roughly. It's all with fours. 400,000, 400, roughly. If you're going at that speed, then it'll take you 4 years to get there. However, that speed is something like 40,000 times the speed of the expected rocket going to Mars. So, don't believe any of this science fiction. You won't get to the nearest star, ever. Period. Maybe in another world, another dimension, God has a different form of physics or whatever. I don't know. At least on our present knowledge, we won't get into any of these places, ever. So, I won't go into this. We will go into the next one. So, the mission duration, as we talked about, was to Mars about 500 days or 1,000 days, depending upon, and we are going to have some time delay. So if you want to talk with people, you won't get the psychological counseling or whatever. You'll do everything by chat. You write your sentence, and then maybe in an hour's time you might get hello. You'll get hello back in about an hour's time. So it's not going to be very chatty. And you say, well, I want to come back. There's no coming back. Because sending the next rocket to get you won't catch up with you. 2 years later, if you have run out of oxygen or energy and you need another rocket to bring you back, well, I don't think, unless you've got 2 years of supplies, they won't be able to rescue you very easily. So we are going to have a real problem. And what kind of problems are we going to have? There are all kinds of complexities we are going to we are going to see. The space flight is really, we have problems with groups, we have problems with culture, we have problems with all kinds of things you're going to be running into. And one of the things we'll talk about is the human factor. Stressors, symptoms, and consequences. So you have different kinds of stressors. Some of them are those associated with the physical environment of going into space. You have obviously the high G's that you're going to experience, And I can assure you, some of these things can be very unpleasant. I didn't mind so much the high G. What I didn't like was the variation between high and low G, which you get in parabolic flight. And if you're on one of those typical parabolic flights, especially if it's American, where they try to put as many parabolae with per flight, because that's the most economic, and they try to get the most out of it. You have 40 parabola on a typical flight, 20 on one direction, 20 coming back. You cannot say stop. You have your 30 seconds of weightlessness to do your experiments, 30 seconds of high G, and in between it's stimulating you to get sick. And in my case, I got extremely sick. And we are given vomit bags. They're little bags with kind of a closure, tweaking closure mechanism. So you can vomit into it and then close it. Because if you don't close it, your vomit will float everywhere. So we wear our flight suits, the typical pilots, acrobatic pilots' flight suits, which have all kinds of pockets everywhere. And these pockets are not just simply for your instruments. I had a camera, I had a computer tied to me, I had all kinds of other things. But sticking out of a few of the pockets, I had these vomit bags. So I could grab them very quickly, have a quickie, vomit into it, close it, put it into another pocket. You have to be quick. Partly because in high G, it's not a nice place to vomit. And in 0 G, you're working. You have something to do. You can't just use those 30 seconds to vomit. You have only 30 seconds, not 4 minutes, 30 seconds in a typical parabolic flight. So these other ones will be very nice when you have more minutes going from Amsterdam to Tokyo or whatever it is. But we only had 30 seconds, and that's not very much. So it was a big problem. Some people didn't get sick. And I was very jealous and envious. They were smiling all the time. You know, like you were smiling in the high G, and I hated those people. You know, you're getting so sick, you're vomiting, and then comes the next parabola. And you say, I want to get off. And then the next one, and then the next one, and then the next, and it continues for 2 hours. And at any moment you say, I want to end my life at this point. I don't want to carry on. I don't give a damn about family, children, whatever, afterlife. I just want to get off this thing, and just even if it means go, and you can't. And you have this general, you know, this wonderful airplane where other people have vomited. Despite all forms of cleaning, it still stinks of vomit. So when you enter the plane and you sit in it and you're going up into space to start off, you already have the preparation odors to help stimulate you, to ensure, even if you were not the kind of person who would vomit, that you will vomit. So I recall I was on one flight. It was in Bremen. We did the flight on a medium-sized plane. And it was one of those days which was a bad day for me. And I realized, almost from the beginning, this is going to be a vomiting day. But I had already done so many flights behind me, so I kind of realized, you know, I would type my commands in the computer, and then 2 seconds before the weightlessness is over, grab my vomit bag and get it over with, and then do the next. It worked out quite well. Except when I suddenly realized I'm running out of vomit bags. Because it had been one of those bad days, but I wasn't under very great stress. I realized I could operate the experiment. I had to write in commands. I had to do this and that and take pictures. I got everything done. I was timing it. I'm just about to vomit. Now I'll do this picture and I'll do that thing, and then quick. Yeah. So the doctor was floating around, and I said to him, hey, I need some more vomit bags. I don't have any more. He said, okay, fine. Give me your old ones. I shouldn't have done that, but I did. I mean, if the situation is bad, you can reuse an old one. Especially if the high G is starting. It keeps the vomit down. Anyway, I gave him my old ones, and he went away. One parabola, another. I realized I can't hold it anymore, and he hasn't come back. So it was terrible. I finally, fortunately, had a lot of kitchen roll, which I got paper. And so I grabbed all this kitchen roll and I put it towards my mouth and vomited into it. Well, this was during the weightless part. Well, it wasn't terribly effective. When I crumpled it together and stuck it somewhere so it wouldn't float around, I noticed my colleague, who had been tied with a tether and he was sitting in his yoga position in midair doing his experiment, and he was going like this. Well, it gave me a certain amount of secret happiness. I wasn't the only one suffering. Later on, he gave the keyboard to one of the stagiaires to clean after the mission. And the stagiaire said, well, what's in there? He said, don't worry about what's in there. I'll tell you afterwards. Just clean it. So the stagiaire cleaned it, and he was eating his lunch at the same time. And then he said, now tell me what it was. And he said, have you finished cleaning it? Yes. He said, well, that was Jim Kass's vomit. He almost vomited his lunch out. I didn't want to meet that stagiaire. He was in another part of the building. So these were kind of some of the real stressors. When I first went for my first job in neurophysiology, and I started my first day of work, what do you think happened? I went to the secretary and I said, where is my office? And she said, before you go to your office, the boss wants to see you. So I went to see the professor, and he said, oh, don't bother going to your office. Before I show you your office in the laboratory, I'll show you one of our special parts of the laboratory. We have a small airplane, a Fuji 200, at the local airport, and we do experiments in it. And surely you would like to see that plane and maybe fly in it. I said, sure, great, wonderful. First day of work, and I'm going to be taken on a joyride. He said, yeah, it'll be a very nice joyride. It'll be one of those roller coaster joyrides. So we went in there. We had to do some kind of experiment, and he plugged me in with all kinds of breathing apparatus and lung measuring devices and neurology devices and all kinds of things. And I sat there in the back, and he sat in front. And he said, we're going to do parabolic flight. And I didn't know what it was. Well, after a few parabola, I knew what it was. Parabolic flight is something to stimulate you to vomit. He didn't tell me about that. And he didn't even give me vomit bags. Well, I won't have to tell you what happened, but the plane was fairly decorated, yes. Afterwards, I was a bit embarrassed, but he was also a bit embarrassed. So he cleaned it up. I had to get a bucket of water and his big kind of thing and clean up. This is part of being a professor, part of doing space work, dipping his cleaning brush that he had from his wife's kitchen and cleaning the plane, while I kind of lay there in his Mercedes trying to recuperate and imagining myself, oh my God. So this was kind of the way it went. And it continued that way. It was wonderful. We had a whole lot of interesting, you might say, experiences, from underwater work to parabolic flight to all kinds of other stimulating devices. We never put our crew through anything without doing it ourselves first. So I did get into many of these machines. One was a flight simulator which rotated. And you sat in the airplane, and then they told you, change the frequency of communications. Well, I was clever. I had learnt finally. Instead of bending forwards, because when the flight simulator is rotating and you bend forwards, you have all kinds of Coriolis forces, and that's very stimulating. So instead, I kind of slid back in my seat until I could reach the knob and turned, and then slid up again without bending forwards, and I didn't get sick. And they kept asking me to change frequency about 5 or 6 times. Finally, they came out and said, you don't get sick at all. I said, I do, but I understand what you're trying to do to me, and I didn't fall for it. This is in Wiesbaden at the American Air Force. They were doing the training. So all kinds, I won't tell you all the stories, but these are some of the stressors in space. Is not only getting sick because of your environment, but it's also the the conditions you are in. You are in a closed cubicle. It's not very big. And you are going to be a number of crewmen. If one of them farts, everybody else smells it. We had a situation on the ground at European Space Agency where the biorack was in space. And biorack was a set of experiments for measuring all kinds of things. And we were, well, I wasn't personally involved, but other members of the team were involved. They saw some signals that were not planned at all. And it kept going up and coming down again. And they were all concerned that the equipment wasn't working properly. And they got the crew and said to them, well, check this and check that. They checked everything out. Still, they were getting such spurious signals, they really didn't know what to do. Until one of the engineers had a brainwave. He went out of the room and he said, I'm going to make a test. And he came back with a plastic bag which he was holding. And it didn't look like anything in it. And he said, now, put one of those sensors that's up there in space onto this bag when I open it. And see whether you get these signals. And we did that. And indeed, we got those spurious signals. And he said, what was that? He said, well, he just farted in the bathroom and put his fart in the bag. So one of the astronauts up there had farted, and it all went into this. These are the kind of real problems. You know, we don't talk about that. When we talk about spaceflight, we don't talk about the problems of urinating and defecating and farting and having such problems. But this is part of the research. The human factors are also analyzing how are you going to get the crew to urinate and to defecate under conditions of weightlessness. Not so simple. We have a step procedure. Now for everything the crew has a step procedure because they're doing so many experiments. And you have to write the step procedure in such a way that you can pin it there and on one page see the whole functional objective. You can't turn pages when you have the thing there and you are floating and you are trying to hold that thing and turn with one hand and turn the experiment on the third and having a fourth hand holding yourself somewhere on a rail so you don't float away. You don't have four hands. You only have two. So you have a big problem. So what do you do? Well, I did some research on this. I invited two cosmonauts to Bremen when I was doing some of this medical operations. Nobody had invited them and asked them how they did things. And being a little bit more revolutionary, I told the agency, and I won the contract, that I would invite the cosmonauts over and ask them a lot of these questions. And we would write a document on it. So I invited them over and we had a long discussion about all these problems. And of course I asked the question about how they went to the toilet in the Soyuz, which took them a number of hours, and on the Mir station and on the Salyut, which was the earlier station. And, well, I got some interesting anecdotes. Well, there is a procedure. If you're going to relieve yourself, should I stop or should I continue? Okay. The instrument that you're going to use has to have a pump, so it'll suck something in one direction. That's what you definitely need. So, procedure is, turn on the pump, put the bag in the cavity, then do what you have to do, then close the bag, and then turn off the pump. In that order. Now, one of the crew had done it so often, he didn't need this procedure, so he did it without the procedure. Unfortunately, he did it in the wrong order. He turned off the pump and then closed the bag. In the split second in between he did that, the contents of the bag had already emptied and was floating through the space station. And you have good air circulation, and you have all kinds of vents, and of course it's making its way between the cracks and the vents. And you have to spend the next hour or so with a a special device with a net on it, trying to fly around and catch those pieces. That's real life on the station. But you don't talk about these things. You don't see it. Did you ever see it on television or in a newspaper? No. But these are the real everyday problems of spaceflight. It's not all wonderful, you see them in their wonderful uniforms or in their sporty. These are the real problems and stressors you have in spaceflight.
10 minutes left, Mr. Kass.
Ah, okay. I think we have to skip a lot of these things. I've talked to you a lot about them anyway. Now, what happens is, this is just talking about all the kinds of problems we have and the results of these problems. And what happens is, what we find is that you do, and I think this is important, when you are feeling uncomfortable and you don't get along with your fellow crewman, and actually the situation is not so good, what are the consequences? Is it so important? It is. You begin to make more mistakes. You start committing more errors. You work inefficiently. You discourage your fellow crew members and you don't communicate. And all of these could have even fatal consequences for your mission. So when anybody says the psychology part is not so important, that's rubbish. It's extremely important. It can be the difference between life and death for the whole crew if you are not getting along with your fellow man, let alone the inefficiency. So what we did was we looked at many of the space agencies has not really looked into the issue of compatibility of crew people. The Russians did, or the Soviets did in the old days. They realized the importance because they've been running a space station there for almost 40 years in space. And they did concentrate on these issues of compatibility. And they really figured they had it down. They had done a lot of research on the issue, and they considered themselves to be world experts. And they were very good. For example, if one crewman got sick before flight, the whole crew didn't fly, because they had already built up a team. And it was very important. The Americans were different. If one crewman didn't fly, his backup flew. The psychology aspect was not so important. But the Russians it was. Why? Because they had such long duration missions, they really had to make sure they worked out. You had people there for 6 months to a year. So it was important. But despite all their care, still, I interviewed one of their chief psychologists in 1994, and they told me that something like 20% of the crew were not compatible, 30% were in the gray zone. Only 40 to 50% could be considered compatible. So it was not down to a science. It's not that simple. So what do we have to do? And one of the things is, we did a number of long duration simulations. I have a whole lot of slides on it, maybe another time, where we locked people up. We did it in the Exems in 92 in Germany for 60 days. We locked 4 people up. And we did it again in the Sphinx 99 mission, where we locked them up for almost a year. And this was an extremely interesting mission. And then we had another simulation of 500 days, which was the Mars 500. Now, what happened with these simulations? We hoped to learn a certain amount about the psychological problems of long duration isolation. What we found was the one mission, Sphinx 99, was the most interesting one. Why? Because the Russians wanted to get foreign participants. And they didn't have any volunteers because NASA and ESA didn't want to participate. It wasn't their idea, and of course, if it's not your idea, then you don't want to have anything to do with it. You want it to be your idea, or you don't do it. You don't do it. These are the political problems. So, because ESA and NASA weren't participating, there weren't any volunteers. So it turned out there were 2 or 3. So they were not filtered as to their quality of being able to get along with the team, or they fitting all the psychological requirements. So they turned out to be very interesting people who caused a lot of problems. And this was extremely interesting for the scientists because we got a lot of interesting data, including a fist fight, sexual harassment, shutting the communications door between the two sections of the simulator so that they wouldn't be able to meet each other anymore, writing to the Human Rights Commission in the United Nations about their human rights being violated. All kinds of things happened. It was unbelievable. And this happened, unfortunately, during the Christmas, New Year time. And we as scientists were told we were not allowed to communicate with the crew directly because we couldn't intervene. Only the psychologists would. Well, the psychologists were all, in Russia, were all drunk at the time. So they couldn't help the crew at all. So when the crew were saying we have a problem, I, for one, didn't even look at my emails because I was told I shouldn't even be bothering about it. And it was Christmas time, and they were drunk, so nobody even bothered about it. And the crew were getting more and more annoyed, ready to go to the Hague's tribunal and everything else because they were getting so. It proved to be a very, very challenging mission. After that, in the Mars, there were three. In one international team, there were 3 men and 1 woman, and in the Russian team, they had 4 men. The 4 men got along with everybody. They were professional subjects for psychological experiments. They had been doing this for years. I don't understand how you can have a professional subject. You have always been trained to behave yourself and to answer the questions properly, etc. And then you had the others who were the other extreme. There were 3 groups, actually. One was a bit of a mixed group, some Russians and some East German, where we were more culturally close to. And then the last one was the totally international one. And that was the chaos, putting the regular Russians and the totally international ones together. You had all kinds of problems, cultural problems. We think we understand our cultural differences. We understand next to nothing, I can tell you. And you can only bother to look at the politics today, and you can understand that our politicians have roughly 0 understanding of international cultural differences. I mean, if they had maybe a 1%, I would say that was very good. But in my assessment, they are absolutely, totally ignorant, and it is a very, very critical issue, these cultural differences between peoples, which may not be so critical here in our working experience, but get to be exacerbated in a space mission. So it's the same problems, the same kind of training, but the problems are exaggerated. So what... How many minutes do I have left? 4. Okay. What we sometimes try to do is there are several things that can be done. One is prophylactic measures in advance. That is trying to select a crew who are compatible, and then giving them all kinds of training, whether it be the Mindy Howard training of stress, which is very interesting, I have to look into that, or whether it be leadership and conflict handling training, which is totally different, but it is very important to have such training because inevitably you will be having that conflict, you will be having lack of leadership, which we have noticed. The leadership situations the roles are going to change drastically. It's not like here in a company you have the team leader and he has his job as that and he's going to do that for the next 6 months. No, when you're isolated on your way to Mars, it's going to change and somebody else will take leadership. And if you're, whether or not you like it, you will be having conflict. So you need some training in advance. That's the prophylactic measures. The other part is, if you are going to be on such a mission, one has to learn and watch the symptoms of our fellow team to see the danger signals. And that you do in advance. And this is also applicable in our everyday life. You see somebody getting nervous, maybe not eating as much, not communicating. There are different signals that one will show themselves, and these are the signals which, if you say, oh, John there is not quite reacting the normal way. Something is wrong. Let me not stress him now that he hasn't completed his assignment. Let me instead take him aside and try to find out what the problem is. Because you notice, you study in advance what are the symptoms for each individual under different circumstances. In German, for example, you sometimes say Sie instead of du. In Russia, you use different kinds of addressing somebody, whether it's Boris Ivanovich or just Boris or what. One can tell the person is annoyed by the way they talk. And that's how the ground also notices it when they are communicating with the crew. The crew will not say we have a psychological problem, never to the ground, never, ever. But you will notice it depending upon how they... If you know these symptoms in advance because you have researched them and you have done enough training on the ground before you go into space, then you need, and you have this pre-psychological and conflict handling and leadership training, then you can notice these symptoms and know this is the point to react and to take care of the situation, because you will be your own therapist if you're going on a 2-year mission to Mars or you're going to live there the rest of life. You can't rely on Mindy or others. It's too late. That's beforehand. It's now you are your own doctor, you are your own specialist, and you have to take care of yourself. Now, there's a whole lot of other things. This is only one of 4 presentations, and each one was about 40 slides. I didn't get to show them all. I'm terribly sorry about that. Maybe another time I can tell you some more of these exciting stories. Thank you.